Alright, my little math friends, we are back and now we are on to 4.3a. We're going to be moving on more with this unit rate and rate of change. We're going to talk about proportional relationships. Okay, what is a proportional relationship? We kind of looked at this in the last video. It is when the unit rate is the same for a situation. Okay, like the speed of the train or the snow falling, it stayed the same for all of those situations. And when that happens, we call that proportional because it's constant. Okay, so we're actually going to use that equation that we worked with or made in the last video. We're going to apply that a little bit today so you can kind of see what that's about. So we're going to write an equation for a proportional relationship. That's the first thing we're going to do. Here's what we have. We have Sally. She's a hairstylist, and the table below shows the amount of haircuts that she can complete. Okay, so look at this. As the hours goes by, it shows how many haircuts that Sally can complete. Alright, so we got to make that fraction, that special fraction that we learned about. Okay, and that fraction is the y over x fraction. Okay, so we have to decide which one of these over here is going to be y and which one's going to be x. Okay, remember, x is the thing that you really can't change. Y is the thing that does change. Okay, so take a look. Hours is going to be our x because we can't change how long or how short an hour is. The number of haircuts is going to be our y because some people can cut more hair in an hour, some people less hair in an hour. So this is the number that is going to change. Alright, so let's set up our fraction. So we're going to have y over x. So our first one is going to be 4 over 1. And then we're going to take a look at 8 over 2. And then we're going to take a look at 24 over 6. And these are just division problems. And we're trying to see if the unit rate is going to be the same for each one of these division problems. And it is. If you do the math, it's going to come out to 4. So what that tells us is Sally can do 4 haircuts in 1 hour. That is her unit rate. So we'll label haircuts HC, and that's going to be 1 hour. 4 haircuts in an hour. That's how fast Sally can cut hair. Did Sally cut the hair at the same rate of change for all 9 hours? Yes, she did. We calculated that out. It all came out to 4 haircuts in an hour. That's the same unit rate. So this relationship is indeed proportional. Okay, because it stayed the same this whole entire time that Sally was cutting hair. Okay, and yesterday we talked about making an equation for this relationship, and our equation that matches this is y equals k times x, and k is just the unit rate that you calculate. So we're just going to put 4 in there for k since we know what that number is. So this is going to be y equals 4x. Okay, that's going to be our equation. Alright, this is our equation. Let's actually use it today, and we're going to use it to make some predictions. Alright, that's what we use these equations for. Okay, we use them to make predictions. Like, for example, we want to know, okay, if Sally is cutting hair at 4 haircuts in an hour, we want to know how many she could do in maybe 13 hours or 19 hours or 247 hours, for example. Alright, so here's our equation. Y equals 4 times x. Alright, so all we do is we're just going to take the hours because we said x is hours, y is the number of haircuts. So however many hours we decide to multiply by 4 will tell us how many haircuts that is. Okay, so like for 13, we're just going to go 4, and I'm going to use a dot here for multiplying. Okay, that means multiplication because I don't really want to use the times symbol because it looks a lot like the x. So we're going to start using the dot. So 4 times 13, if we do the math on that, that's going to get us 52. That tells us she could do 52 haircuts in 13 hours. Okay, what about 19? Alright, simple. We're going to do the same thing. We're going to take 4 times 19. Using this equation, we're just taking 4 times the number of hours, 19 hours, multiply that out, and that's going to get us 76 haircuts. Alright, 76 HCs. We might as well throw an HC over here too, and that tells us what we get. Alright, that's what we use the equation for. Let's take a look at some other examples, and we'll work on this some more. We'll get some more practice on this. Here's another situation. We're back to Sally, the hairstylist again, and this time we have this situation that tells us what she charges for a haircut is showing down here. Okay, so here's how many haircuts she did, and this is what she charged for doing those haircuts. Alright, we're going to find the rate of change for this. Basically, we want to know how much she was charging to do one haircut. That would be the unit rate. So we're going to make a fraction. Alright, and we need to make those y over x fractions. So we need to decide which one of those categories up there is the y and which one is the x. Which one changes and which one does not really change. Okay? In this situation, alright, in the last situation we called the haircuts y and the hours x. In this situation, haircuts is going to be x and the amount charged is going to be y. Okay, let me tell you why we have this one x and why that one is y. Okay, let me use my own hair for an example. Okay, if I go to get my hair cut, if I go to Great Clips, or if I go to Noel's, or if I go to Country Cuts here in Palmer, then no matter where I go, they're still going to have to cut my hair. Alright, the amount of hair that is on my head that they're cutting, yeah, it'll grow, but the actual shape of my head, it's not going to change. It's still going to be them cutting my hair. That doesn't change. But depending on who I go to, they will charge me different prices for cutting my hair. So the amount that gets charged for cutting a hair changes, but the actual haircut itself, like the hair that gets cut, doesn't really change. So that's why this one is y, this one is x. We're going to set these fractions up now. So we have, the first one is 32 over 2. We'll see what that divides out to. And then we have 80 over 5. And we have 96 over 6. And then over here, let's go with 128 over 8. Alright, and if we divide that out, every single one of these comes out to 16. Okay, so that means Sally was charging the same price for every haircut. She is charging $16 to do one haircut. Okay, that's just kind of like a fraction bar there to show $16 for one haircut. That's our unit rate. It was the same every single time, so we're going to call this proportional. Okay, it had the same unit rate, $16 every time. The equation for this is going to be y equals our unit rate, which is 16 times x. Alright, and now we can use this equation to answer some other questions like, how much would she charge for 11 haircuts? Well, haircuts is x, so we're just going to go 16 times x to find out y, the amount charged. 16 times 11. If we do the math on that, that is going to get us $176. That's how much she's going to charge for 11 haircuts. What about for 16 haircuts? Well, we're going to take $16 times 16 haircuts, and that's going to get us $256 if we do the math on that, and that's how much she would charge for those haircuts. Alright, that's what we use that equation for. Okay, let's take a look. We got to try this problem. See how you guys do. See if you can figure out these categories. Which ones is your y, which one's your x. Set up your fractions. Build your equation, and then we'll check and see what you guys got for some answers.